KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Neet, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In this class, first we will discuss some information regarding nuclear fusion. Okay, so nuclear fusion we started in the last class, but we didn't complete. First we will discuss the information what we didn't complete from nuclear fusion. But we discussed what is nuclear fusion, and then after completion of that, what is the nuclear fusion reaction. Okay, what is the nuclear fusion reaction, that and all we completed. So what I am saying is here, if you observe carefully, when two lighter nuclei combined, right, when two lighter nuclei combined to form a heavier nucleus, that is what the process of nuclear fusion. In clear, we can say that the process in which two or more light nuclei are combined into a single nucleus. The process in which two or more light nuclei combine into a single nucleus with the release of tremendous amount of energy, is called as nuclear fission. So you remember simply, that is what nuclear fission is, the process in which two or more light nuclei are combined into a single nucleus with the release of tremendous amount of energy, right? Okay. So like a fission reaction, the sum of masses before the fusion, that is what in case of lighter nuclei, is more than the sum of masses after the fusion, that is what bigger nucleus, and the difference in mass appears as the fusion energy, right? Okay. So there itself we discussed one nuclear fusion reaction also. Okay, right now. So this is what we already discussed in the last class. So now we start with the second point related to nuclear fusion. See here, for the fusion reaction to occur, the light nuclei are brought close to each other with a distance of 10 to the power of minus 14 meters. Please listen carefully, For the fusion reaction to occur, the light nuclei are brought closer to each other with a distance of 10 to the power of minus 14 meters. Full stop. This is possible only, right? This is possible only at very high temperature to counter the repulsive force between nuclei. Okay, this is possible only at very high temperature to counter the repulsive force between nuclei. So it is the important point we have to keep in mind. For nuclear fission reactions to occur, there is a requirement of high temperature. And the distance between the two nuclei what are going to fuse also important, that is what distance of 10 to the power of minus 14 meters. Okay, right. Next, due to this reason, the fusion reaction is very difficult to perform. Right. The inner core of sun is at very high temperature and is suitable for fusion. In fact, the source of energy in sun and the stars and the stars is the nuclear fission reaction. Nuclear fission reaction, right? So whatever the information we had here regarding the nuclear fission, every point is important. So here these 2 points he is saying, for the fission reaction to occur, right, the distance between the two lighter nuclei is of the order of 10 to the power of minus 14 meters, and there is a requirement of high temperature. Due to this reason, so it is very difficult or rare, okay, very difficult, so that you can see rare to perform. The inner core of the sun is very at a high temperature and is suitable for fusion. In fact, the source of energy in sun and the stars and other stars is the nuclear fission reaction. Okay, so it is what practical application. So the last 3 lines, this is from here to here, he is giving a practical example, that is what a live example, the natural example, that is what in case of sun and in case of stars. Okay, so the source of energy is the nuclear fission reaction, and already you know that because of high temperature in case of sun, there is a chance it is suitable for fusion. Okay, right. Next point, see here, radioactivity, right. So it is the natural phenomena. This phenomena is very, very important, right. So because of this much population, that is what nearly that is what 750, right, 750 crores of population in this world, to meet the energy requirement of all the peoples in the world. Nowadays that is what the realistic source, and nowadays which is very close to us to use or to utilize, already we are utilizing, that is what nuclear reactor, right. So there, in case of nuclear reactor, this is what radioactivity is a mechanism, right, for the functioning of a nuclear reactor, right. Our discussion is not nuclear reactor, our discussion is about the natural phenomena radioactivity, okay, right. See this, the phenomenon of spontaneous emission of radiations, by heavy elements, is called radioactivity, right, full stop. The elements which show this phenomena, are called radioactive elements, right. Don't see like a definition, you just try to understand every word, right. That is very important for us, right. So then you can easily digest the concept, right, which helps us while solving the numerical problems also related to Neet and JEE mains. See here, the phenomenon of spontaneous emission of radiations by heavy elements means having more mass number, is called radioactivity, right, full stop. The elements which shows this phenomena are called radioactive elements, okay, right. See, there are like points wise given, so point by point I will explain you, just be concentrate. First point, radioactivity was discovered by Henry Becquerel in uranium salt in the year of 1896. Radioactivity was discovered by Henry Becquerel in uranium salt in the year 1896. Second point, after the discovery of radioactivity in uranium, Pierre Curie, right, so the scientist name is Pierre Curie and Madame Curie, right, Pierre Curie and Madame Curie discovered a new radioactive element. Discovered a new radioactive element called radium. Which is 10 to the power of 6 times more radioactive than uranium, right? So till now, till this finding of this radioactive element, that is what radium, we felt that, we means the time peoples, right, the time physicists and the time scientists believed and feel that uranium is a powerful radioactive element. But afterwards, Pierre Curie and Madame Curie discovered a new radioactive element called radium, which is 10 to the power of 6 times, 10 to the power of 6 times, right, 10 to the power of 6 times more radioactive than uranium, okay, right. Next, third point, see here, third point, some examples of radioactive substances, right, some examples of radioactive substances. So radioactive substances means not only uranium, not only radium, there are many, right. So for example, uranium, okay, right, already we discussed, and radium, right, okay, thorium, polonium, neptunium, these are also radioactive substances, right. So some examples of radioactive substances means uranium, radium, right, thorium, polonium, neptunium. So 5 elements are given here, etc., right. So these are all examples of radioactive substances. Next, fourth point, radioactivity of a sample cannot be controlled by any physical or chemical changes, right. See here is an important point. Radioactivity of a sample, radioactivity of a sample cannot be controlled by any physical or chemical changes. See here, fourth point, radioactivity of a sample cannot be controlled by any physical or chemical changes, right. In the bracket, pressure, temperature, electric or magnetic field, right. In the bracket, physical means pressure, temperature, electric or magnetic field, right. So the radioactivity of sample cannot be controlled by any physical or chemical changes. Physical means you just keep in mind, like pressure change or temperature or electric or magnetic field. You know, it is a natural phenomena, as I told just before 2 minutes. Radioactivity is a natural phenomena, is the phenomenon of spontaneous emission of radiations by heavy elements is called radioactivity. As we discussed in our previous classes also, you know, when there is a huge mass number and huge atomic number, naturally it is unstable. So when it is unstable, you know, in the process of getting stability, it release energy, right, it release energy in the form of radiation, right. So when once we expose to that radiation, we will get harmful diseases, right. So it is very hazardous to human body, not only human body, rest of the world also, right. So that is what happened in case of atom bomb, right. And similarly, what happened when a nuclear reactor explodes. That's why in case of nuclear reactor, so these radioactive elements will keep under, you know, highly thick walls, right, highly thick lead walls. So this highly thick lead only can protect, right, can protect that radioactive substance. So the thickness is very high. That is the only source, right. And I am not talking about only lead, but the thickness is very important, okay. But generally we are using lead, highly thick lead walls, that is what to protect radioactive substance or to protect the rest of the world from radioactive substances. So when it is under there, okay, but when once you take it out, any radioactive substance, right, when once you take it out, it releases energy in the form of radiation, so which is very dangerous to the human life as well as rest of the world also, right, even plants, something also, right, because when we are getting continuous energy, it is a problem, no, okay, right. Next thing, fifth point, all the elements with atomic number greater than 82 are naturally radioactive. all the elements with atomic number greater than 82 are naturally radioactive. Next point. The conversion of lighter elements into radioactive elements by the bombardment of fast moving particles is called artificial or induced radioactivity. Is an important point because this is what artificial or radioactivity, right? So generally in physics, in science, what's happening? First we are going to study the natural phenomena either accidentally or wantedly, right? After completion of that, based on that we developed many artificial things. For example, in case of magnetism, so first we found that lodestone as a natural magnet, then we studied the behavior of lodestone. Afterwards we developed so many artificial magnets with different shapes. That is what nowadays artificial magnets are more powerful than natural magnets. In case of bullet train, right? In case of magnetic trains, in case of magnetic speed breakers, in many places in our life, in our day-to-day life, we are utilizing magnets. Similarly here, naturally radioactive element is exhibiting radioactive behavior. That is what emission of radiations, spontaneous emission of radiations. But we can also experience artificial or induced radioactivity by our effort. That is what he is saying here. The conversion of lighter elements into radioactive elements by the bombardment of fast moving particles is called artificial or induced radioactivity. Next, seventh point. Radioactivity is a nuclear event. Radioactivity is a nuclear event and not atomic. Full stop. Hence, electronic configuration of atom does not have any relationship. With radioactivity, right? So what is electronic configuration? What is electronic configuration and what is how to write the electronic configuration, right? That is already we know from chem. See here. So radioactivity is a nuclear event and not atomic, full stop. Hence electronic configuration of atom does not have any relationship with radioactivity. Okay, right. Next, what is alpha, beta, gamma decay? First we are going to see what is alpha decay, then what is beta decay, at last we will discuss what is gamma decay. See here alpha decay. When a nucleus emits an alpha particle, when a nucleus emits an alpha particle, its N and Z values, capital N and Z values, each decreases by 2 and A decreases by 4. See here, this is what X, A, Z gives rise to Y, A minus 4, Z minus He42, right, plus He42, okay. That is what I can say here. So what I am saying is, you please observe carefully what is happening when alpha decay took place. Right? So when alpha decay is going to take place, what is happening there? Its mass number A decreases by 4 and its atomic number decreases by 2. Okay right. So when its mass number is going to decreases and atomic number is going to change, what happens to the neutron number? Right? So you please keep in mind, that is very important for us, okay, which is very important for us. Based on that only we are calling it as alpha decay. Next, What is beta decay? What is beta decay? So in beta decay, n decreases by 1, z decreases by 1 and a does not change, and a value does not change. So observe carefully, x, a, z, x, a, z, that is gives rise to y, a, z minus 1, sorry, y, a, z plus 1 plus e 0 minus 1, e 0 minus 1, right. Next, gamma decay. See here, when a nucleus is placed in an excited state, either by bombardment with high energy particles, either by bombardment with high energy particles, or by a radioactive transformation, it can decay to the ground state by emission of one or more photons called gamma rays or gamma ray photons with typical energies of 10 electron volt to 5 million electron volt, 10 electron volt to 5 million electron volt. This process is called gamma decay. So you please try to understand the situation what they have given regarding the gamma decay, because he is not talking about any atomic number or mass number or neutron number. Simply he is saying that when a nucleus is placed in an excited state, either by bombardment with high energy particles or by a radioactive transformation, it can decay to the ground state. By emission of one or more photons called gamma rays or gamma ray photons called that is what simply we can say that either gamma rays or gamma ray photons. But what are the typical energies they have given? And then this process is called as gamma decay. Okay, right. So in this class we discussed one important point. That's what we didn't complete in our previous class. Here regarding the nuclear fusion. So what he is saying is, for the fusion reaction to occur, the lighter nucleus brought close to each other with the order of 10 to the power of minus 14 meters, and then the repulsive force, and then temperature requirement is also very high for the nuclear fusion to occur. And after that he is saying the repulsive force between nuclei, that is what is going to counter because of this high temperature. Due to this reason, the fusion reaction is very rare. Otherwise you can also say that very difficult to perform. The inner core of sun, it is what practical application. The inner core of sun is at very high temperature. That's why it is suitable for fusion. So in fact, in our nature, in this entire universe, in fact, the source of energy in sun and the other stars is the nuclear fusion reaction. Okay, right. Next, radioactivity. So the phenomenon of spontaneous emission of radiations by heavy elements is simply called radioactivity. So the elements which show this phenomenon are called as radioactive elements. Here they have given 7 important points regarding the radioactivity. The first point is who discovered Henry Becquerel in uranium salt in the year of 1896. Next, after discovery of radioactivity in uranium, Curie and Madame Curie, Pierre Curie and Madame Curie discovered a new radioactive element called radium, which is 10 to the power of 6 times more radioactive than uranium. Next one, that is third point. They have given some examples. So uranium, radium, thorium, polonium, and then neptunium are the examples of radioactive elements. Some examples of radioactive elements. Next, he is saying radioactivity of sample cannot be controlled by any physical or chemical changes. All the elements with atomic number greater than 82 are naturally radioactive. Next, you can also experience this phenomena artificially, right? That is what the conversion of lighter elements into radioactive elements by the bombardment of fast moving particles is called artificial or induced radioactivity, right? Full stop. Seventh one, radioactivity is a nuclear event. Radioactivity is a nuclear event and not atomic. Hence, electronic configuration of atom does not have any relationship with radioactivity. Next, what is alpha decay, what is beta decay, and what is gamma decay, right? So, when a nucleus emits an alpha particle, its n and z values each decreases by 2 and a decreases by 4. So, this was the example of alpha decay, that is what nuclear reaction. And then beta decay means, in beta decay n decreases by 1, z increases by 1 and a does not change. This is what the nuclear reaction which shows beta decay. Then gamma decay. When a nucleus is placed in an excited state, either by bombardment with high energy particles or by a radioactive transformation, it can decay to the ground state by emission of one or more photons called gamma rays or gamma ray photons with typical energy values here mentioned, and this process is called as gamma decay. Okay, right. So in our next class we will continue with the next continuation information. Thank you.